So, hey everyone, what an amazing menu we have here. I appreciate my thanks to the organizers as well as the venue partners, such an amazing menu. So, yeah, a bit about myself. I'm Abhishek. I work at Trado Logistics as a senior engineer. So at Trado, we are trying to, build a platform for logistics, and we are also involved in sports as well. So we are working for grassroots programs and grassroots levels in football. So if you are interested about the sports, topic, do hit me up later on. Okay. So as for today, I'll be talking about the offline experience which we can give to the users. So it's basically offline first, but online ready. It's not just only offline. We are also making it online ready, so all the content, all the data is shared across devices, across users. So what exactly is offline first? So you guys have used WhatsApp, and you guys might have used also Slack, right? So in WhatsApp, whenever you open the app, all the chats, all the messages, they are there instantly. There is no loading time, nothing that sort. But if you open Slack, there is always some sort of loading happening there. There are chats being loaded and all that. So both apps have a different type of architecture. What Slack has done is they wanted to always keep a fresh set of data, as well as in WhatsApp what they wanted is very crisp UI. In the whenever you open the app, the UI is there, the data is always there. So that approach is offline first. So very conventional way of doing things is you have your app, right? You want some data, you send a request, it goes into loading phase, then you get the data and you show on the UI. A very conventional approach. So let's say you're building a mobile app, right? You're fetching lots of data, you're showing to the users, and once the user has seen gone through 2-3 couple of screens, the user closes the app. Then once again the user opens the app. Now what happens? So all the data which you have loaded earlier, you are trying to load it again, right? It might be the case that not each and every data is refreshed every minute or so. It might be that some data, it can be cached, it can be even if the data is 1 hour stale or let's say 1 day stale, it's okay. But in this particular case, what will happen is whenever your app opens, you're fetching the data again and again. So very conventional way of doing things. So to avoid that, what we can do, what many of us does is add a bit of cache layer in between. So this is basically the cache level. So what happens is whenever you are trying to load the data first, your initial request response happens, you get the data, and then you cache it on your front end side, right? But this cache is very, it's not the cache which is stored in the disk, it's in your in-memory cache. It's very lightweight, so all your recent requests are being stored. So let's say when if the user goes back to the previous screen and all that, there is no loading happening again and again. You are just getting the data from the cache and you are loading in the background. So a very popular approach, or I would say a very popular library is React Query. A lot of us have been using that. So it gives you a cache. You can work with that cache as well. It's one thing to have data for one session, but let's say the app again, the user closes the app, again opens the app, it's gone, right? You have to start again. What you can do is you can have add a persistence layer to the React Query. Let's say you're implementing this cache with React Query, so you might have added a persistence layer in the React Query. But what will happen is over time it won't be efficient enough. Right? You will start getting lots of data, you are storing lots of data, and querying of the data and all that, it becomes, the process becomes a bit slow. Unless you are trying to, some sort of invalidation or revalidation logic you have added, some sort of cache busting mechanism is there. Unless that is there, and even if that is there, the data is not structured according to the front end, right? So that might be the case. So even this approach, it falls a bit in, let's say if you wanted a very snappy UI, it lags in that way. So here comes the offline first approach, right? So what is exactly offline first? So right now every Android device, every iOS device has its own database, right? Every device has its own DB, and even if let's say a native DB is not present, you can ship a DB file with your app bundle, which you can utilize. So there are a lot of mechanisms by through you can have your data stored offline. So one is the local file. So basically your file system which is there on your mobile apps. Another is like key value store. So very common and like everyone might have heard is async storage. Lot of people have used async storage and lot of people don't like that because it's very slow. Another is MMKV, and then we have the local databases, right? So SQLite is something which almost every device has, and you can leverage that, or you can come up with your own DB or any other DB package. So there is also a famous library Watermelon DB and also Realm DB. So Realm DB is something sort of equivalent to a MongoDB. So the workings and all that are quite similar, and Watermelon DB is on top of SQLite. So the advantage of using Watermelon or Realm DB over a normal SQLite DB is these both DBs are reactive in nature. So what do I mean by reactive? Whenever your tables change, whenever your data changes, the hooks which or let's say the functions or the components which you are listening to the particular table, they are also getting updated, right? Let's say it was just a normal DB. What would have happened is you are updating the DB, you would also have to write logic to update the UI as well. But with Watermelon and Realm DB, since they are reactive in nature, once the data has been updated, your UI also gets updated. So that is a very plus point. So let's talk a bit about all the three possibilities which we have. So let's say you went with local file for some reason. You wanted to work with local file, you are not comfortable with DB and all that. My first approach would be, let's say if you wanted to store data in your local file, please don't do that. Because what will happen is you'll have to manage your local files as well. We'll have to be efficient in storing the data. We'll have to be efficient in retrieval of the data as well. And as the file goes on increasing, as your data goes on increasing, the storage mechanism, you will have to think a lot about that. How can you index the data? How can you query the data efficiently? So files is generally I wouldn't recommend, but if there is a use case, you might go with that as well. Second is the KV, right? The key value storage. Common example, async storage. Few years back, it was like quite famous. There were no other good alternatives for async storage, but right now we have very good alternatives which are very quick in nature. So one of them is like MMKV. MMKV is really good to store key values, but what happens with key values is you cannot store a very large set of data. It's good for storing smaller chunks, but if you wanted to store large data, let's say you are building something like a Twitter app, right? And you have the user is going on scrolling posts all day long, and let's say you wanted to store hundreds of posts, or let's say 200 or 300 of posts, and you are trying to do that in MMKV, it won't work out very well. It is mainly focused for key value, so it's better to use it that way. It's not meant for querying the data as well. So even if you wanted to run some sort of query, some sort of search functions, it's not very useful in that. So there comes the local DB. So as I mentioned earlier, while choosing the local DB, it would be best if you choose a DB which is reactive in nature. The examples are Watermelon DB and Realm DB. Other DBs are also there, but these are like the quite famous ones. So the main difference between Watermelon and Realm would be, so Watermelon is an SQLite kind of, it works in SQL nature, and Realm DB is like the document store, similar to like MongoDB. It's your use case, whatever you want to work with, it's fine. So again, you have fetched the data, the user performs some sort of actions on your data, right? And again, you are sending the request. So again, the conventional way of doing things is you update your state, maybe it Redux, a Zoostand, or just a uState. You update the state, you send the API request, then the request follows with a response, and then any related queries you are trying to update. Again, what happens is you are doing two to three things here. You are updating the state, you are updating the query, you are updating the query cache as well. Maybe you can optimize with the query cache into the state entirely. But again, that happens, so that doesn't provide a offline support again. So what you can do here is you can update your local DB, right? So already you are querying the data is being stored in your local DB. So whenever a mutation happens, whenever you are changing the table and all that, all you have to do is worry about your local instance, and the DB will take care of syncing the data with the remote storage or let's say another peer device. So you don't have to worry about state. Once you have integrated like a local database in your app, you don't need to have a Redux instance, you don't need to have a substand or whatever state management you are using. You just have to worry about the DB, and since it's a local DB, the operations are quite fast. It's not like you're taking 300, 400 ms. It's quite faster than that as well. So you just update your DBs, and the DB syncing happens in the background, and all the data is synced. So that is how online readiness is achieved. So first offline is via the DB, and online via the syncing logic. So let's take a look at how we can have our DB instances and how we can query and all that. So for this demo, I have gone with RenDB. So let's take a look. So okay, so this is like quite a simple app, a simple to-do list for the win. Everyone does a to-do list nowadays. So let's go inside here. I'll just enter a to-do. Let's say book a cab. I click on add. A to-do is added here. So nothing is done via state. Everything is done via DB. So it's stored in DB, and the retrieval is done. Like the DB collection is being shown here. So yeah. So all the to-dos are here. So let's say, I hope this is visible, right? Everyone in the back? Yeah, cool. So the thing with DBs is you get the functions as well, like the sorting, searching. Let's say you wanted to perform some sort of vector search also, that is also possible with the DBs. So that is one major advantage of DBs over the KV store or like the simple file storage. So let's say I just wanted to reorder. I can just reorder in the way the things were added. If I want to search something, just hit search. It will just. So these are like the basic DB operations which you are doing, and as you can see, the response is quite fast since it's locally, the DB is in local mobile app, it's there. One thing you have to take a look at is the syncing as well. So let's say you have shared this to-do list with another user, right? So whenever any operations happen, so the DB would take the changes and it would push onto the server so that the other user can as well take a look like what changes are there. So this is like a very simple to-do app, to-do list. Like it has roughly, I would say, 5 rows and something like that. So let's say if I delete something, I delete the environment part, and we have here quite instant changes. So let's take a look at the larger list. So here you can see a quite lot of rows are there. So even if I am scrolling, it's not lagging at all. So what is happening here is the list which I have used is the React Native flat list, the primitive, like the basic list. It's not flash list, it's not recycler list, not anything other than that type of. It's basic React Native flat list. But why the data is it's not like it's actually working very crisply fine. So what is happening here is, even though the data set which I have, like let's say I have 10,000 to-dos. What is happening? The DB gives a live object to us, and via the live object we are querying and we are showing the data. So whenever we are showing the data, only the data which is visible on the UI part, that is being pulled from the DB and shown, not the entire list is being loaded. So that is another optimization you are getting out of the box. So this is basically the live objects are something that are part of the reactive nature of the DB. So whenever you are querying the object, or let's say whenever you are manipulating the object, you are not actually directly changing the object in the DB, you are changing the live object. Live object is basically holding the reference to those tables and all. So that is one aspect of it. So let's take a look at the code, like how we can integrate the database. It's quite simple. The one thing is that, so let's say if you are working with Expo, it cannot be done in Expo Go. You'll have to build a development build of it. You'll have to extract the development build, and then you can add a database. So let's say even if you are adding a database incrementally, so let's say just two to three strings are there for which you are using database, you have to ship a new build. It cannot be done over the air since it's entirely like the native files are being changed. That cannot be pushed over the air. So this is our basic app, and our app is wrapped with the provider that gives us all the REN hooks and all the functionalities which we need for our app. It has a schema version, so we'll talk about schema version later on. And here is the schema. So schema is basically your table. This is the to-do table. These are the types which are being referenced in our JavaScript code, and this is the schema which will be there in the DB. So here you can see there is this name primary key, which are like the required properties. Another would be the object ID. So object ID is being generated on the fly. One thing to note is you can see the default. The callback has been passed to a default, not the exact, so not something like this, not the exact value, but a callback. Why it happens is the schema has been cached. So let's say if you do something like this, it will try to generate the same ID again and again, and it will throw an error. So that is something you have to take a look for, that you need to pass a callback. Again, same happens at the created as well field. So you have to make the callback, otherwise all the objects which are being created, they would be created at the same time. Another flag is the synced at flag. So here you can manage your sync status as well. So there are like quite popular libraries out there via which you can sync your data, or you can have your own logic as well to sync this stores. So this is the basic schema, nothing fancy. So let's take a look at our list. So what happens in the list is we have the basic filters here, the search filter, sort filter for the UI which you can update. We have the to-do list being brought up, and this is the basic final markup here. As you can see, the flat list is the normal flat list. These are the hooks by which all the operations are happening. So there is one add hook, there is one remove hook, and to mark the completion of the to-do, there is mark. So let's take a look in the hooks as well, how it works. So what I've done here is I've taken the rel instance and have wrapped around callbacks and all that. There is another approach. You can use the internal use query hooks as well. So there is use object, use query, and I guess there is one more hook. So you can use that, or you can use the rel entire instance as well, and you can write your custom hooks and work with that. So the problem with use query and all that is it's specific to a component. So you have to it cannot be easily like shared across other components. But with rel, since you are getting the entire rel instance, you can share across the components. Another thing to note is, even if you are getting the rel instance, like I said earlier, it's a live object. Since it's a live object, there is it's not like taking your memory or all that stuff. Whatever you query, it will serve you that. So here we are getting the rel instance. Simple add to do. Everything happens inside a write transaction. Even if you have to create, even if you have to delete, every operations happen inside the write transaction. So here is the rel.write, and and then we are just passing, we are creating the rel dot create, and we are creating the to do. For the remove operation as well, so we are getting the remove, we are getting the rel, sorry, and we are taking the object specific via the ID which we want to delete. Also, let's say right now in this example I only have a to do this thing collection, right? So if you had multiple collections, you just have to pass the parameter here. So I have passed the to do class here, so it knows that I want to query on the to do class itself. So I get the ID which is in the string, I convert it into the bson ID, and I get the to do and I then delete that. Simple. And as well in the completion, like marking whether the to do is complete or like unmarking. So again getting the to do and then marking it. That's it. Nothing much, because what happens is the rem.write, if you see this function, it knows what difference has occurred, and based on that difference it updates on the database. So I have to just, don't have to worry about the immutability and all that. I just have to take the variable and change it. That's all. So yeah, basic hooks which have been exported from here, and then for both the list like these are like the simple basic hook. I just add a wrapper around it for both the screens, for the longer to do and for the shorter to dos. And so let's take a look at like how this sorting and how querying happens. So like I mentioned earlier, there is also this hook use query. You pass a specific collection to it on which you want to query, and then it gives you these methods filtered and sort. So I would like to tell you that these are not run on the JavaScript, rather these are run on the DB side itself. So even this sorted, so it's sorting on the basis of created at. Let's say I gave it another key, it would sort on that base, and then there is the filter also. So like it takes an entire query string, and like it's pretty much straightforward, nothing fancy. But one thing I would like to again highlight is that everything is happening on the DB level, so it's quite fast, and you don't have to worry about your app hogging a lot of memory and all. It basically queries and returns the result, and that's it. So basically what happens is, this is how you approach this is how you tackle the offline first aspect of the app. So you are getting all the data, you are storing all the data, querying, and having all sort of operations on that. So now how about syncing the app, right? So you also want the app to be synced across users, across devices. So every database has something called as listeners and something called as pre-commit hooks and all. So even the RenDB has a listener to the collection, listeners to the entire Ren instance as well. So you can take a look into the listeners, and you can write your own custom syncing logic, or there are also other packages available. So there are some sync solutions there. The very recent one is the PowerSync. So PowerSync is a package that helps you connect your local instance with the remote one. It is mainly for the SQL, but recently they have also started providing for the RenDB as well. There is another thing called CouchDB. So it is similar to like Couchbase, CouchDB. So it's the vendors from there. They are working with CouchDB as well. Recently I found out about Zero also. It's like quite early. It's in alpha stage, but that is also one thing you can use for syncing across devices. And then electric testament. So you can just go through all this. They have their own set of systems, own set of APIs by which you can sync your store. Another thing I would like to mention is earlier RenDB used to support the syncing via Atlas Sync APIs, but right now they have deprecated it. So if you are thinking of going with RenDB, the syncing part you will have to manage on your own. But if you are going with, let's say, PouchDB, or let's say, I would say, I don't remember the exact another DB, but PouchDB has their internal syncing logic. So all the data would be streamed and synced across. Also, let's say you wanted to build some app like Figma or something like that, like a very real-time connection. So syncing can be done by WebSockets or WebSockets as well, or via HTTP. It's up to you how you want to send the packets and get the data. So yeah, so the online part is done, and the offline part is done, and the online part is done as well. So that is how you can build your apps which are like offline first, but as well as online ways. And that wraps up my presentation.